Points A, B and C lie on a straight line in that order on horizontal ground. A box of mass of 5 kilograms is pushed from A to C by a horizontal force of magnitude 8 newtons. The box is at rest at A and takes 3 seconds to reach B. The ground is smooth between A and B. Between B and C, the ground is rough and the coefficient of friction is 0.57. The box comes to rest at C. Determine the distance AC. Like all good mechanics questions should always start with a diagram. So we've got a block here. We're going to mark on A, B and C. This force here we're going to mark on as 8 newtons. This is smooth and this part here from B to C is rough. Okay, we're just going to consider A to B. We know it takes 3 seconds to go from A to B. So resolving horizontally using Newton's second law, we're going to have that F is equal to ma. So we're going to have 8 is equal to 5a, which will give the A acceleration for AB is going to be 1.6 meters per second squared. Marking that on our diagram. And now using S is equal to ut plus a half at squared to find this distance here, knowing this is 3 seconds time and that the initial velocity is 0 because it was at rest. So we're going to have SAB is 0 times 3 plus a half times 1.6 times 3 squared, which will give me 7.2 meters. We'll also need to find the velocity when we get to B. So using VAB is U plus AT, that will give me 0 plus 1.6 times 3, which will give me a velocity of 4.8 meters per second, which we're now going to mark that on our diagram. So that will now become the initial velocity for the stage BC. So finding for B to C, so we've got our block. Okay, so we're in this part here where it's rough. So we'll need to put on the weight, which is 5g newtons, and the normal reaction, which is R. And then there will be this extra force here acting against this one, which is mu times R. Now we can find R quite easily because R minus 5g is equal to 0, therefore R must be equal to 5g. So finding the frictional force using F is equal to mu times R, so it'll be 0.57 times 5g, which will give me 27.93 newtons. So resolving horizontally, we're going to have 8 minus that frictional force, which is 27.93, is equal to the mass times the acceleration, so 5a, and therefore ABC will be 8 minus 27.93 over 5, which is minus 3.986 meters per second. So we'll mark that on our diagram. We'll also mark on the initial velocity, and we want the final velocity to be 0 because it's at rest at C. That's good because these act against each other, which means it's slowing down. So finding the distance BC using v squared is equal to u plus 2as. The final velocity is 0, so 0 squared plus the initial velocity, which is 4.8 squared, plus 2 times minus 3.986 times s. And therefore SBC will be 4.8 squared divided by 2 times 3.986, which will give me 2.890 meters. The distance AC will be that plus the initial distance AB, which we found to be 7.2. So 7.2 plus 2.890, which will give me 10.09 meters, which is 10.123 significant figures. Now to go with this video, I've got this GeoGebra app. The link I'll put in the notes of the video. So here we have the whole thing set up. So if we press start, and then we get the whole thing coming up, and we get it stopping at C here. So we get the distance here exactly. We can see that AC is roughly just over 10 meters. Okay, I apologize for the interruptions there to that video, but I thank you for watching. In the notes of the video, you'll find a link to my video site where you will find thousands of videos to help you with A-level maths. Thank you very much for watching.